you've decided to write this table to disk. 5 million rows, 20 columns, the same data from the row versus column video. Now, which format? 5 honest choices. Same rows, same answer, and the smallest file and the largest are 7 times apart. Every format here answers 2 separate questions. Is it text or binary with an enforced schema? And is it laid out row by row or column by column? CSV and JSON, text, no schema, row-oriented. Avro, binary, schema'd, but still row-oriented. Parquet and ORC, binary, schema'd, and columnar. Here's the same one record in each format. CSV, a plain text line, comma separated. JSON lines, the same line, but every field name spelled out again. Avro, binary, the schema lives once, not repeated per record. Parquet and ORC store it column by column. You've already seen why that matters for scans. Same rows, same columns. 5 very different files. JSON lines is the biggest, 2.25 gigabytes. Every field name, repeated, 5 million times. ORC is the smallest, at 304 megabytes. Avro's binary encoding beats CSV's text, even though Avro is still row-oriented. Smaller doesn't mean cheaper to write. Parquet is both the fastest to write and near the smallest, 12.5 seconds. Avro is the slowest by far, over 4 minutes, 20 times longer than Parquet, for a file barely bigger. That's the cost of a pure Python writer encoding 1 record at a time. A production Avro pipeline, in Java, or over Kafka, wouldn't pay nearly this much. Now the query. Average 1 column over all 5 million rows. CSV takes 18 seconds. JSON lines takes 91. Parsing every key on every line is expensive. Avro takes 43 seconds. Binary, but still decoding every field of every record, row by row. Parquet and ORC don't even add up to 1 second between them. Columnar storage skips straight to the column you asked for. So why can Parquet and ORC jump straight to 1 column when Avro can't? The answer is metadata, a footer the file keeps about itself. A Parquet file splits into row groups, and inside each one, every column is stored on its own. The footer records where each column sits, and its min, max, and null count. So a reader seeks straight to the column it needs, and skips whole row groups whose min and max can't match the filter. ORC does the same, with a finer index and optional Bloom filters. That's why it's the smallest file here. Here's what actually reading each one looks like in Python. Same query, 5 formats, 5 small APIs, and DuckDB reads 3 of these directly, no pandas step at all. Here's the one property none of those bars show you. What happens when your schema changes? Add a field to Avro with the default, and a new reader opens an old file. The default just fills in. An old reader opens a new file too. It just never asks for the field it doesn't know about. CSV and JSON don't break either, but nothing enforces it. That default lives copy-pasted in every reader's code, not in one schema everyone resolves against. That's Avro's actual job, not analytic scans, events that keep changing shape, flowing through something like Kafka for years. 5 formats aren't 5 competitors. They're answers to different questions. Text formats win when a human needs to read the file, or nothing else has agreed on a schema yet. Avro wins when the shape of your data keeps changing, and old and new readers both have to survive it. Parquet and ORC win when the file's job is to be scanned by column, not read record by record. The format isn't a default, it's a decision on axes a single benchmark number can't show you. Text or binary, schema or none, row or column, fixed shape, or evolving. Pick the one that matches the question you're actually asking the file.